All right, so we've answered part A on this investment model. Let's look at the following parts. What will the account balance on January 1st, what will be the account balance on January 1st, 2028? This is asking for the output of the function after a given amount of time has passed, which 2028 is going to be 10 years after, right? So this is asking us to evaluate the model. A of 10, remember we have an elapsed time model, so we need to input the function, clear this. And our function is 500 times 1.04 caret x. Okay, and I put a pair of parentheses around this, mainly because I'm paranoid. But in this case, I didn't actually have to. Some of your calculators will actually show you the exponentiation, and that's nice because then you sort of feel better about what it's being applied to. But the parentheses just are extra assurance that my function will do what I want it to do. And I want to now evaluate the model at the input 10. We could have inputted this as 2028 minus 2018, but this will do the trick. So we get 740.12. Okay. In what month and year will the balance reach $600? All right. Again, need the model for this, and this is a calc intersect question because $600 is an output and we want to know the time that it takes to get to that. I'm going to need to mess with my window. Right now I've got my window starting way off from a previous problem. Now remember, we reset the clock, so this is going to start at time 0, and I probably don't need to go to 2010. I could probably just go to like maybe even 20. If you're not sure about setting your X max and you want to actually be a bit more exact about it, you can go to the table and see when this intersection occurs. And it happens, actually, see right here, it happens between 4 and 5. So really that tells me that 20 is plenty big, in fact too big. I could probably just go to 10 and then do zoom fit, and I should see a decent intersection now. Okay, and we're going to do calc intersect. And my intersection is 4.6486, so 4.65 years. So the raw amount of elapsed time is 4.65, but remember that this is, we want the month and the year, so the year is going to be 2022 because I started in 2018 plus 4, so that's 2022. And then 0.65 to determine what month that would be. I'm going to multiply that by 12, and that gives me the decimal portion of a year. So 7.8 months into the year, which is in August of 2022. So 7.8 months, August. All right. What about part D? How long does it take for the account balance to double? So I want to pay special attention to this because doubling time, which is what we're actually finding here, is a very commonly computed value in terms of exponential functions. And here's our first example of this. So we want to know how long it takes to double, and $500 is what we started with, so this is the time to get to $1,000. But the interesting thing about exponential functions and doubling time is that the doubling time is actually always the same for the exponential function, for a given exponential function. So it doesn't really matter what your value is, it will take you the same amount of time to double it. So if you start off with $5, it'll take you the same amount of time to get to $10 as it would if you started off with $5,000 to get to $10,000. So exponential functions have the doubling time as a constant. So with that being said, how do we find it? Well, we want to know how long it takes to get to 1,000, so this is still just a calc-intersect question. I might have hit graph a bit prematurely. I forgot to look at my window, but maybe our old window will suffice. Oh, and it does not. It's not big enough, so I need to see more vertical. So let's do zoom fit. And as this is taking its sweet time to graph, I guess I should also mention that I didn't really do this the right way. I should have looked at my X max as well, and you see now I'm paying the price for that because you might not have noticed it, but it actually drew the 1,000 line at the very top of the screen. But I need to know when they intersect, so I need to go to the table and actually find the intersection so I can set my X max. So we're just going to click down through here until we see 1,000. And there it is, 17 to 18. So that means I need to get up to like 20 or so. Let's go 25. And then we'll do zoom fit with that. And now I think we'll see the intersection. And then once we see the intersection, we'll do the same procedure as before. We'll do calc intersect. There it is. And my intersection is 17.67 years. To double. So this means every 17.67 years I will double what I had previously. Okay. All right, so there's a nice little example of using an financial exponential growth model. So we're going to dig a bit deeper into the form of the function now. We've talked about this form f of x equals a times b to the x, and we talked about this b value is the growth factor. But there's another very common way to express this function, and that's what you see down here. And this is in terms of what we call the growth rate. So I want to stress that this form and this form are interchangeable. They are saying the same thing. They're just stressing different parts of the function, okay? So in this form, R is the growth rate expressed as a decimal value, not as a percent. And yeah, again, we're using R kind of an overlap because we were using R to represent the correlation coefficient in the previous section. Again, this is just something you have to deal with. But R represents growth rate here. Okay. when x increases by 1 unit, f of x increases by r times 100%. So there's a connection, of course, between the growth rate and the growth factor, and it's a very important connection, and let me highlight this with some stars. Here's stars, okay. So the growth factor, b, is just equal to 1 plus the growth rate as a decimal value. So this may kind of look scary to you, but I think once you see some examples, some simple examples, you'll get the idea. So let me draw a few, or just write a few simple examples. So, for example, if I have a 10% growth rate, then R is equal to 0.1, because that's the decimal form of this percent value. And then B is equal to 1 plus 0.1, which is 1.1. Okay. So one way of thinking of this is that if we have a 10% growth rate, then your actual growth is 110%, because you have 100% of what you started with and then another 10% on top of that. So basically you're going to be multiplying, and this is, remember when we talked about the growth factor, if you go over 1 unit, you multiply where you were by the factor. And so every time we move 1 unit horizontally, we will move up vertically by a factor of 1.1. Okay. So if you have no growth, you're remaining constant, then you just have 100% of what you started with, you end up with. And so then your factor would just be 1, right? Which, by the way, remember we said b is not equal to 1, and that's why, because that wouldn't actually have any exponential growth to it. But anyway, the point is that b is equal to 1 plus r, where r is the growth rate. Okay. And we will use both of these forms. This f of 0 stuff, let me write it like this. I will not use this f of 0 notation hardly ever, but you should know what it means. It's just the initial value, a times 1 plus r to the x. Okay. All right, so I want to look at that investment account that we were using a moment ago, that model. This is the same function that we had just a second ago, and just kind of break it down. The annual growth factor, as we noted already, is 1.04. So every year the balance gets multiplied by 1.04. That's what a growth factor means. It increases by a factor of 1.04. What is the rate? What is the growth rate? Well, if we kind of split this 1.04 up like so, that's still b, but now I'm writing b in the form 1 plus r. So I just separate the 1 from the decimal portion of it. Then that 0.04, that is my annual growth rate, which in percent form is 4%. So every year the balance increases by 4%. And it's just very common that we report rate values in terms of percent, but when we're computing with them, we use the decimal form. So that's something that you have to get very familiar with, is converting this to a decimal and then adding 1 to it to get the factor. Okay. All right, and now we're going to play around with this a little bit. Actually, we'll do this in the next video.